Hey everyone, welcome back to another YouTube video. My name is John Hammond, and in this video, we're still taking a look at the HackTheBox University CTF, or the Capture the Flag event that was going on this past weekend. So hey, without any further ado, we're not wasting any time here. Let's hop over to the screen and get to the good stuff. In this video, I would like to showcase the Slippy challenge from the web category, and hopefully we can start to cruise through a little bit more here. So let's take a look at the challenge information. It says, hey, you found a portal for a firmware upgrade service I can read, responsible for the deployment and maintenance of rogue androids hunting humans outside the Tractor City. The question is, what are you going to do about it? Okay. So this challenge is started on demand. It has a Docker container to start up and a downloadable portion. So let's go ahead and download that, and let's get this Docker container started. That is that middle power button here. Docker is offline. Let's bring that online, and it'll just shoot out a little IP address and port for me to play with. So let's get back to our terminal before we dive in. Let's make a directory for the web category. Hop in there, and let's make a directory for our Slippy challenge, and we can go ahead and download and retrieve that web download Slippy here, and then let's go ahead and unzip that just as well. So there we go. Looks like there's a lot of stuff that extracted, so we can hop into that directory, but we should honestly go take a look at what that service really is up here. So I'll go ahead and paste in that host and port number, and this is what we are greeted with. Ladies and gentlemen, it looks like we have a Slippy firmware upgrader. Current Slippy Jet version is 3.03. Okay. Please select a newer version of the firmware. I did it again. Firmware tar.gz file to upload. Okay. I'm gonna hit Control U on the page just to kind of view the source. Nothing else here. You could do your kind of usual shenanigans, maybe hopping over to like a robots.txt, fire Nito or whatever, but okay, that's not found. It gave us an interesting JSON response, kind of oddball, but this is what we're up against. So I'm assuming, hey, it's just a file upload, it sounds like, and we give it a tar.gz file to upload. Now, does it need an actual tar.gz file? We don't know, but we have the source code, apparently. We have this Docker file, which could showcase some goodness, and I should, I guess, download this new version of Sublime Text, whatever. But internet was screaming at me to go ahead and, like, hey, make sure, Google Chrome was updated, and I get it, So let's go ahead and just download this thing. I'll pause the video. Okay, ladies and gentlemen, I have updated Sublime Text, and now the internet has no reason to scream at me. But they will anyway. I'm kidding. So we just have a Python Docker container. We are installing Supervisor and pip and Flask. Okay, a Flask web application. We may very well have been able to see that had we checked out the network traffic here. I'll open up F12 or hit my developer tools. In the network tab, I'll go ahead and refresh this page. I hit Control-Shift-R on my keyboard. So viewing this IP address and the actual request to the page here at the very, very top, you could, if you wanted to, go see the response headers over here. And this will tell you, hey, we do see a server header for workzug, however you pronounce that, Python version 3.10. So nice. Okay, so I mean, hey, we could very well have seen that. I don't know if you're using the Wapalizer shenanigans, but hey, that could tell us just as well. We can see what this is built on. Python 3.1, or excuse me, 3.10, jQuery, Flask, yada, yada, yada. So slick, cool. We see that just as well in the source code, but if you were doing a little black box, didn't have all of the, the structure and design of it behind it, then that could be handy. Looks like we copy in this challenge directory into the app directory in the container, make a supervisor config, expose a port, disable PyCache, cool, and run the supervisor. Okay, so what else do we got here? We'll hop back over to our terminal and the build Docker script. Build Docker just removes the container image, rebuilds it, and runs it with that exposed port. So nice and easy. What about that config? Was there anything in there? Yeah, just the supervisor config. Looks like it's going to end up running the run from the app and go ahead and log files to that. So running as root. Interesting. Good enough. What do we have in the challenge directory? Let's hop over there. And I guess I'll go ahead and run tree. Maybe that'll make things nice and fancy for us. This is the application directory that we have here. We also have a flag file, which is not, of course, the legitimate flag, just a local copy, so we would be able to explore and play with it. And you have a run.py script, which was the actual program and utility, the script that the supervisor was running. Interestingly enough, looks like we are running on that port LEET as suggested by the container, exposed and listening on the local LAN, local area network. I like redundancy. And debug is actually true. So the debug mode is on, but use eval x or use eval expressions doesn't, I believe, doesn't allow us to get to the, like if the debug mode was on, /console. Right? So yeah, so you won't be able to run commands in the debug environment and debug console. Neat. We are more interested in what happens in the application main code because that apparently carries everything else in there. So we saw that in a tree here. We have blueprints that defines the actual routes of this Flask application. Looks like a configuration file in the main.py that we're interested in. So let's take a gander at some of those. Look at the main.py, and this is it. Looks like we have Flask and JSON, and the blueprints that we're going to end up reading through our config, and okay, blueprints that we actually have configured and set up right for our routes. Looks like this was our error handler, which is why we saw the JSON values in those error messages, not found, not allowed, and bad request. So let's explore more. Let's see what this config file has set. Looks like an application util. That looks like an actual code written in this, so we could explore that util script and generate as a function. Looks like it generates a secret key. I'm assumingly random, doing some magic there, and absolute path from the os.path library. Upload folder looks peculiar. Looks like that is still in the /app root, that we kind of rooted the application that we saw in the Docker container. Again, our application folder, and then static and archives, which is odd. Oftentimes you'd see in static, like, hey, JavaScript files or CSS files, etc. But we are running in debug mode for a deployment, development config, etc. Anyway, looks like we could take a look at what that util.py is up to. This has a functools tar file and temp file, along with OS installed or imported. This is a Lambda function to quickly generate, hey, that generate function. Looks like they do just a random bits, I believe, or bytes, I might be wrong in there, and getting the hex encoding of it from the argument passed in, the number passed in, right? And then we have an extract from archive function here, which allows us to pass in a file, supposedly, put it in a temporary directory that's been created, yep, and save it there. Oh, sorry, dragging code around, and test if it is a actual tar file. If it is, it will open it, reads it as a gunzip or gzip file, extracts everything into the temp directory, and determines, okay, the extract directory is going to come from this upload folder with an F string, format string here, and a generated location. Probably a secure path or something to kind of have that a random location based off random hex values. Make these directories, if they exist already, that's a-okay. And then we extract the file names and return that eventually after we loop through each of these and close the tar file. So each of the entries in that tar file will grab the name. If it is reg, a regular file, I'm assuming. So let's go ahead and actually just take a look at that tar file Python documentation. And yeah, here we go. Just a pure Python docs and 3.10, perfect. What is that? Is reg. Same as is file, supposedly. It returns true if the tar info object is a regular file. Okay. So, I mean, you could very well in like, symbolic links, right, or hard links. You could, in compressed archives like a zip file or a gzipped tar file, you could include symbolic links, but it looks like it won't allow us to do that, which is a bummer because it takes away a little bit of a potential attack vector, right, if we were able to do some ZipSlip idea, right, where you could maybe actually pull back and climb up directory trees, or climb up, hey, the parent directory, the parent directory, the parent directory, to be able to control where something lands as you extract something. And this might be exactly what we're looking at, considering the name of this challenge is Slippy, after all. is the tar file Python ZipSlip? Is that a thing? Oh yeah, there's actually a bug report on this. Looks like. Was this for the older versions though? Python library for tar file has not been patched. This is all 2019, however. Oh, they show some examples here. Is this the very, very same, however, in 2010? I don't know. Maybe this implementation is wrong. I mean, we could just try stuff. Realistically, if we extract the files into the temporary directory and then we end up renaming them, as in, hey, here's our file name from the extract directory that we might be able to slap, hey, ... and climb the parent directory trees in. You could, because it's going to take the temporary name that it had and replace it with what would have came through from our extract directory, just adding these in, right? Based off the name. You'll still be able to do the ZipSlip vulnerability, or in this case specifically a tar gzip file, and then maybe that could very well work, right? We can start to experiment with this, right? There's enough talk. I think we have a decent idea now of what this application kind of does. We haven't dug into the templates here. This is just the HTML file as we saw, right? Nothing else kind of fancy in here. We could look at the main.js, and actually that's an interesting point because there is no form element in this HTML code here. You would have to explore the main.js, and that is in static, right? So archives is empty because that's where I'm assuming where we're going to upload things to. Here's our CSS images, I'm assuming for everything that we need to display those fancy pictures. But the main.js is really where, hey, okay, we're using some jQuery. We're checking if this archive file has been changed, and we retrieve files and we upload them. The way that we would upload them is an asynchronous function. Hey, we disable multiple submissions, good enough. Show the loading container, which is probably something just display, hey, it's going up to the internet, uploading it, have a progress bar, set timeout, blah, blah, blah. Ultimately, we're allowed to upload a file by posting to an API endpoint. Okay. But, okay, we need to, I guess, check if we actually get a valid response. Has own property list, it looks like, in the response. And then it would display it and showcase them. But otherwise, if it fails, please make sure this is a valid tar gz. There's a comment here. Oh, set response message. Not super helpful. Looks like populate list is another function that would display all this, given the file names that are in the tar gzip file that we upload. So now that we have, again, pretty decent understanding of what this is doing, was there anything else that I'd kind of missed? Oh, the blueprints would be very worthwhile, right? Because, yeah, we return our index.html, but the API / unslippy endpoint that you saw we could post to will end up running that extract from archive function inside of the util.py. And then if it were to succeed, if that were to actually return valuable files, right, rather than a completely empty list, it will give us a list object JSON with the 200 status code. Otherwise, it doesn't. So that's probably how we can figure something out, right? Let's experiment with that. Let's go ahead and make kind of just a dummy file. I'll touch a hello, and maybe we'll echo like a, hey, please subscribe into that or something. I don't know. And we can go ahead and create a tar archive with tar C to create. I like to use V for verbose. And then Z is what we will need to create a gzipped file here. And then F for the file name, we'll call it just a test.tar.gz, and we would include this hello file. So now, hey, that's been created. We can see that right there. I'll go ahead and just open the file browser here so you can see, yep, totally legitimate file. There's hello, and you can see my please sub string in that text editor there. Nice and easy. We could go ahead and upload this. Let's see if it will play nice here. So I'll upload, cruising back to the web display. We'll use our test.targz, and there is our extracted list here. So /hello, and if I hover it, you might just barely be able to see the URL here. Oh, looks like it was able to download one already named hello. But you might be able to see, and my face is in the way now, that is static /archive / a random hex value. But what if we were to try and create something with those ... parent directory traversal climbing? We could do that. And honestly, I'd like to weaponize this a little bit and make a Python script to do this. So let's do that. I'll move out of the parent directory so we're actually in this, and we'll call this just a tinker.py, I suppose. I know that I will need to post to the URL. So let's actually keep track of all of that. And we know that we'll go post of the URL plus /API unslippy was what we saw there. And we need a file, correct? Yeah. So that should be, I think, and I always have to look this up, Python requests upload file. It would take a file name as we create, but I mean, here I am on Stack Overflow, right? Can I just pass it sort of an object type or an opened file? Yeah, I really don't want to have to write something to disk. I want to be able to generate this all kind of on the fly within Python. And you could do this, I think, with just a regular string IO or bytes IO. There's got to be a way to do that. Let's try and figure it. Python, so tar gzip in memory, I suppose. Recursive extract in memory. Is there a way to create? Here's an idea. Create. Oh, hello, Danny Webb. Sort of. God, this looks gross, though. I want a gzip file, guys. Not a C, any of those shenanigans. How about? Sorry. Googling together. Compress an object in memory. Yeah, maybe this just works fine. Okay, so they take, there it is, the IO and the tar file syntax. Of course, we need a library for tar file, but creating an object or file in memory, we will need IO. So before I end up posting stuff, let's try to just carve out making a tar file. Yeah? Of course, we need a tar file. But they would open and read the bytes out of a file. I don't really want to do that. I'm gonna swipe this just to totally remove it, because data could very well be bytes that I will create on my own. Like here, we can create our own. I'll just make that script again. Hello world, please sub, and we'll create a file handle with io.bytes. And we could very well funnel in, I believe, just our data, right? Or did they do that? Okay, they do that included here. Did they actually answer this? Yeah, so add file is what we'll add this within the tar file object. And we were looking at that in the documentation here. If we wanted to actually make more sense of this, it's tar info, add file. But it will take a tar info object. So that should be all that we really need. But I'm going to bastardize some of this code here where I will, yoink, and go ahead and grab, hey, the file handle that we were already building, writing a gzip file based off of a tar info given a name that we might like. We could configure that to be something like, again, we'll use our, I guess, hello world.txt so it doesn't try to download it again, but we'll call that name. And then the info size is going to be the length of the data that we create. We add our info object given of source F, but source F was the initial bytes given from data that we had read. So they call it FH for no reason. Oh, just previously. Is FH even used in this? Oh yeah, no, because they use it for an IO bytes object to store the tar file in memory, and then our actual contents of the tar, like our compressed object. So let's kind of do both of those. We'll say source F can then equal that IO bytes IO, and I think it says initial bytes. Yeah, initial bytes is the keyword argument set to the data. Nice and easy. So at that point, we have a file that we could very well just write out if we wanted to, given this new file handle that is added and created with a tar file. So just for the sake of our proof of concept, let's try and run this code. I'm going to hit Control B, and I need requests. Wow, I should have seen that from the beginning. I'm sorry, you guys were probably screaming the entire time. I have build view on. Let me disable build view so that I could go ahead and run this. And in our directory here, we should now see a test.tar.gz. Again, I'll open this up in Nautilus. The file browser, you can see there's our hello world.txt with our hello world please sub present. So that Python code did it for us, but honestly, I want to be able to weaponize this, as I said, and just send that along to the data here. Can I open that file handle, or it should already be a file handle on its own, would it not? I believe it would be. Did I lose my Hey Python requests upload? Learning on the fly. Syntax that I'm never able to memorize. Yeah, you open it, given a name, and that name in our case should be, I think, file, because that is what the JavaScript ended up pulling out. If we were to go back to that main.js, input type equals file, 0.files.length, or archive file. Where it pulls that from there, does it not? Index.html just takes a index or input. Oh yeah, ID and name equals archive file. So let's just use archive file is what we do want there. How about that? So let's do an R to request.post, and let's print out. Maybe we should make this a session so we can see it all. Let's do create a session so that way once we upload this, we'll be able to actually see it being present on the page as we reload it after we've uploaded it, right? So we can print r.text, which should just tell us, hey, success. But then we could totally do a s.get of URL and see if that actually returns any good output in text for us. Let's try that. Oops, broke something. Oh, it had an extracted list. Oh, no. This is just the output of the page. That's not super helpful. So we had a bad request along somewhere. I must be uploading this the wrong way. That's my file handle, is it not? Can I, or does that need to be passed to open for some reason? No. That's the contents of it, not. Let's Google Python requests upload bytes IO. Yep. Request.post files equals files and file.getValue. We just did this. That's literally the same syntax that I was doing. Am I not doing that correctly? Posting to API unslippy, which is what we did. Here's just my sanity check. Let's try this again. The network tab open. Let's try and upload our test there. Oh, let me refresh that page because I think it was not happy with me having already done that. Yeah, we post to it/API unslippy with file binary as shown. Oh. Should it be file? Yeah, name file. How about that? Request files file. I was wrong. Totally my fault. How about that? There we go. Now it will return our actual list of applications that's been uploaded. Sweet. And it tells us, okay, where it would have put that, right? That's actually kind of handy. It won't actually tell us in the session back, apparently, but that's kind of okay, I think, because we could now go access just this page, could we not? Let's go to static hello world.txt, and even in our instance, back over here in our URL, it's been uploaded. There it is. So now we could try to do some more damage, right? Because we wanted to try and climb the directories. We were in the randomly generated directory, up 1, right? So then up 2 for archives, and then up 3 for static. And get to like the root of the application and /app/application. We might be able to just climb all the way up, right? Can we not? So I'm putting an extremely annoying amount of potential parent directory climbings, like moving up the file system. And then let's try and clobber, because debug mode is on, right? We could very well maybe just overwrite one of these like actual source code files, because debug mode will reload, and in Flask anyway, if debug mode is on, it will reload the like structure of the application, because it could detect the changes that you might have made. So let's try and, can I just overwrite main? Like, can I do that? I don't know. I don't know if it'll run. It may very well not. Or routes or something if we try to do out of the different applications. But this works just fine, right? Can I kill all of our application error handlers and then try to... Let's do an app.route for a /flag. How about that? And then let's return, maybe just open. We know this is in /app/flag, and then just read out the contents there. Will that work? Or am I just going to obliterate and destroy everything? Do it. Hello? There we go. Okay, so checking this back out, we uploaded all the way and then climbed way up so we could get to application main.py. Now let me try and refresh the main page. So index would still exist from the blueprints, but does flag exist? No. I did that wrong somehow, some way. Can I mess up the blueprints? Routes.py? Because main imports application, imports route, web, and API, an app. Oh, sorry. Web. Maybe we should do it from web. Can I steal this code and maybe just make the same changes? Let's make a web.route return the flag as a function. So let's go /flag, flag, and then again our open syntax in Python, right? So app flag, flag.read. Yeah? Have that displayed out. Let me go back home, refresh the page before I kind of fire off this payload. So hit Control B in Sublime Text, send it. And now theoretically, we've modified the blueprints. If I had the right routes, did I? Is it called blueprint? No, blueprint S, so plural. So let me refresh the page. Index is still okay. What about /flag? Not found. What the heck? Is it actually restarting these? As it should be? Am I like not seeing a piece here? Does this need to have some like updated timestamp or something? Just tar file let me modify like the modify time? Yeah, okay, cool. So I could just change the info.m time maybe. And let's import time to see if that for some reason makes a difference. I am climbing up plenty of these. Let's go ahead and remove that bottom output. I don't think we need that anymore. But I want to maintain like the regular functionality of the application here. So let's try and run that. Uploaded. Let's go back. Let's go to /flag. What? Is it literally just having like a greater modification time or something to know that it changed, or was it like an invalid Well, I mean, it was still extracting. Allegedly, it had the success. So Weird to me. But hey, I'm not going to complain here. I will, I think if it's okay, take this a little bit further yet again, kind of as we did in the previous video, because this works, but it is relying on the fact that debug mode is allowing us to change and modify the Python code that's present here. Something that I think could be a little bit more interesting, and I might be wrong in the cases here or the scenarios where this would actually work, but something we could additionally do is maybe modify the templates here. I want to make sure, though, that it is me properly recreating and re-uploading these things. So let me try and concatenate something stupid like, yes, you did change. How about that? Does that display okay? If I try and run this with a new modification time, right? Yes, you did change. Is it seriously just the modification time that's allowing that to happen? And we changed again. Save, run, uploaded. It's seriously just that modification time. So that's interesting to me. So let's do that again. Oh, need to run the thing. Need to run the thing. Actually execute, please. Refresh, and we change again. Okay, so let's try some crazy shenanigans where we were actually going to clobber or do some template injection, which is kind of a fun idea, right? Because we could very well just change one of the index, like the index.html on the templates that are being loaded here. Because I don't know if it's necessary for Flask to reload to be able to, resend that template. Sorry, I bumped the microphone there. I don't know if you heard that. So let's change index.html and let's totally deface the website to make it whatever we want. But then you could change this challenge to a little bit of a server-side template injection just as well. Can I just drop the config here, like as if I were using Jinja as a templating engine? If I run this, okay, now we should theoretically be clobbering index.html. That's kind of cool, not going to lie. And there's our secret key, right? So we could form cookies. We could do all the damage that comes from server-side template injection, which just as well, you could start to climb up the Python MRO and get, again, arbitrary code injection. Let's experiment with that for just a little bit to, take this a little bit further. The way that you do that is, again, climbing that Python MRO. SSTI. There's probably some payloads, all the things to do with that. And there are a lot of good write-ups that showcase how to do this. And I think I've shown it in other videos before. But as we're using Jinja as the templating engine in Flask, we're able to reach and see variables or evaluate things with these mustache style syntax. Config is that kind of global one that you could see in Flask, but you could maybe retrieve some or call other functions, right? So folks showcase some really interesting ideas where what if you were to try and climb up some of the Python basic types and objects and try to find how objects are represented and maybe what potential libraries are imported or things that you could actually even pull out and use. So this is fun. Here's the magic syntax where we just take a basic Python type, climb up its class, its MRO structure, maybe grabbing an object index, getting the subclasses out of it, and then you could have a giant listing of all of the things, all the types, all the objects that this application, this web service offers you. So let's try and run that payload. Refresh the page, and here's a ton of stuff. What I like to do, because there's so much of this, is that you really do need to index the correct thing that you want to work with or use. The most valuable thing for us is like a sub-process module or a reader or like the open handle something, or OS module, etc. So I copy all of this out, and then I'll try and split on the commas and create new lines. So that way, hey, we could very, very easily, based off the line numbers of our text editor here, determine what the index would be for something that we actually want to use and take advantage of. Some of the classes might not be all that useful for us, but if we could get to some classes that are pulled in from libraries, like do they have anything cool that we could abuse and exploit? Iter tools, func tools, string context lib, subprocess. Here we go. We have a subprocess.popen. So we could totally execute code. Are there anything else that we might be able to use to read files? There might be a type down below. I'm getting to the bottom. Never mind. Apparently not. Oh, I mean, I guess type. Could I find like a file handler open? Could maybe do it with temp files. I'm not positive. Let's get back to that sub process one. Let's use popen here, which is, as we see, 223. If we were considering this to be 0 based, we see our 224, but we subtract 1 because our line numbers start at 1. So let's again modify our script and index this at 233. Right? Execute. I'll hit Control B, go back to this page, and I hit date time. Ooh, lol, what? Should that have been, did I read that wrong? Did I typo anything? 223. I'm an idiot. 223, run. Now we've got subprocess.popen, and we could very well just open a command to run. Can I use like who am I, maybe? I don't know. Run. Now we have return code none, args who am I. Can I like read the standard output of this as a command? I don't know if I'm getting that syntax right again. Nope, totally broke it. How do I do that? Can I retrieve that class? Or maybe I'm pulling from a different thing. Oh, here they showcase it a little bit. They use popen. And grab the index it. So now you can finally control the web application. Wait. What did you do? How did you do? Oh, yeah, you pass it a little bit better arguments. So you do need to tell it, hey, run this from a shell. The keyword argument, hey, run from the shell. True in Python. Let's Control B that. Check it out. Hopefully my Jinja application is still broken. We need, what is it? Standard out equals subprocess.pipe. Can I do that? Or I just kind of want communicate, right? Rather than trying to actually execute it, I want to start the process and then read it, the output that it comes from. That's something that communicate could allow us to do. That had none. Do I not know the who am I command? How about like pwd? Is there another argument that I need to be supplying here? And I should know this. I'm totally rusty. Oh yeah, standard out equals -1. So standard out, which standard out should normally be like a subprocess.pipe, but we don't have the context of what subprocess is in this MRO climbing and SSTI injection that we're doing. Server-side template injection, right? So that .pipe constant though is just -1. So we could supply that just by knowing that value. Let's go ahead and run this. Let's see if we have any better luck. Now we should at least know a present working directory, and we are in app. Excellent. So we could index this to 0, and we could make this, hey, now any other shell that we'd like to do. Again, run who am I? Oh, sorry. And that should be root. Excellent. So that, again, is a way and a method for us gaining code execution. And it didn't rely on us, maybe, again, I'm not positive on this. It didn't rely on us needing the debug mode to be able to be restarted and re-kicking things. It's just going to return the value of and the contents of our index.html. But because of our ZipSlip vulnerability, we could do anything that we wanted to. Upload and have arbitrary write as we would want to. Let's try and retrieve those byte values out and then decode them so we have a pure string. Let's rerun the exploit. And there is our flag in another different way, maybe a little bit more interesting and more fun than our original trick or you might like completely stomping over the application. whatever tickles your fancy, whatever tickles your boat, whatever floats your fancy, you know? That is that challenge, ladies and gentlemen. Thanks so much for keeping up with me. I hope I wasn't rambling too much, but if we were to submit that flag, if we were to go get some points for this, we'd be climbing up that scoreboard even more. So, hey, I hope you enjoyed this video. I hope this was kind of a cool thing to explore and work through. Some good lessons learned in that web category and that web challenge there. I'm excited to go tackle some of the others. And thanks so much for listening in and watching, everybody. I super appreciate it. If you'd be willing to do some of those YouTube algorithm things, you know, that would be a great help. Please do hit that like button, leave a comment, subscribe, all the incredible things that help this channel grow. If you'd be interested in supporting, or you're offering some extremely generous donations, you know, that super warms my heart, there's a Patreon and PayPal link in the description. So thanks so much, everybody. I hope to see you in the next video. Take care.